Perhaps the lonely reaches of the thinly settled American West have seemed of small value to those with a practical turn of mind. However, this is no longer true, for the very lack of population makes these vast stretches of dry, stable land ideal locations for missile testing vital to our national defense. Yet, notwithstanding the importance of such programs, our missile testing agencies have never forgotten that safety of life and property must be assured. That missiles can be fired safely over populated areas, that the present state of the art allows it, has been successfully demonstrated in the conduct of several overland programs in the last few years. In fact, a vast area of the western U.S. has become an overflight corridor for both missiles and various test vehicles of the military services. From sites such as Gilson Butte, Utah, numerous missiles have been fired into New Mexico to impact in White Sands Missile Range, a distance of over 400 miles. Missile flight safety is the responsibility of the Commanding General, White Sands Missile Range. The range is an element of the Test and Evaluation Command, U.S. Army Materiel Command, and is America's only all-land national missile range. The flight safety responsibility involves a number of different tasks. For example, on firing days, inhabitants must be cleared from a predetermined zone surrounding the launch site. Such a zone may cover 250 square miles or more. Roadblocks must be set up for public safety reasons during the brief time of flight. Numerous tracking instruments along the hundreds of miles of trajectory must be prepared to gather flight data. So must transmission systems for rapid distribution of data. Computers for instantaneous processing of flight information. And real-time displays for use during flight. Now for a broad look at 3 overflight missions, let's go to the Gilson Butte area. As we arrive on the scene, missile flight safety engineers, in accordance with the operation plan, are installing a safety system. Other flight safety personnel man radio transmitters. A coded signal from one of the transmitters will cause the missile safety system to detonate a destruct charge, should it be necessary to terminate the flight. Direct communications link all transmitter personnel with the senior missile flight safety officer stationed near the launch site. A word from this man can cause either the missile's destruction or shut-off of its propulsion. This display, called an IIP for Instantaneous Impact Prediction, is the safety officer's key tool. At any given time, the trace shows where the missile would impact if propulsion were to cease that instant. These guidelines indicate flight limits which enable the safety officer to confine the missile to safe areas. However, the guidelines are just one mechanical aid. More important in assuring impact in a safe area is the safety officer's special knowledge and experience. Unshaded areas indicate a population of less than 1 person per square mile and are designated emergency impact areas. Sensitive points such as towns and cities are clearly marked. All shaded areas are to be avoided. A second major flight safety tool is this display of the missile's velocity vector throughout flight. This line indicates the expected performance profile of the missile to be tested. During flight, the flight safety officer watches for significant deviations from the expected profile. The plot also provides such information as occurrence of booster burnout and second stage ignition. A good deal of redundancy in the information used is necessary to make certain that essential data is obtained. Decisions must be made in seconds, and the probability of equipment failure must be minimized. The third major flight safety tool is telemetered recordings of vital missile flight data, such as motor chamber pressure, longitudinal acceleration, and guidance system output. Again, evaluation of telemetry data as to its degree of acceptability depends upon the knowledge and training of the flight safety officer. He must be able to interpret rapidly the displays of missile data, both individually and collectively, as to their effect upon flight safety. Presently, we will see a Pershing missile fired from Gilson Butte, Utah. Safety actions have been taken for the flight pattern. An area cleared of personnel is called the abort zone. Should a missile malfunction shortly after launch, it is brought down in this safe area. A still larger area called the commit zone has also been cleared of personnel. Malfunctioning missiles can be brought down in this area at any time prior to first stage burnout. The first stage of normally functioning missiles fall into this zone, as shown here. The second stage, now in normal ballistic flight, will coast until its motor is ignited. Motor ignition takes place on schedule. Now the safety officer closely monitors velocity and impact prediction displays to be sure that the flight remains normal. He watches for indication of second stage motor shutoff at the scheduled time. Should this fail to occur, he must send the destruct signal at the proper time to assure safe impact. In this depiction of a normal flight, the warhead and the trailing second stage impact as planned. In this flight, something goes wrong. In seconds, the safety officer determines the most favorable off-range impact area, and at the proper instant, sends the destruct signal to assure safe impact. Now let's view an operation as it actually happens. As the final seconds are counted down, flight safety engineers watch the missile for instability, tip-off, or any other abnormal flight condition not readily apparent from the data displays.
Transmitter, the receiver is on. Send me a channel 3. Drop it out. Put it back. The field is green. Roger, firing pitch.
Transmitter is green.
Roger.
White Sands plotting room is green.
Roger.
Range control, this is flight safety, over.
Come in, flight safety.
Missile flight safety.
Is green.
Green received. Green River Pershing project. This is range control. The range is green.
5, 4, 3, 2, 1, fire.
White Sands, I have good data and will retain responsibility until first stage burnout. At that time, I will pass responsibility to you. I read you. Data is also good here.
At White Sands, some 500 miles away, another phase of flight safety operations is taking place. The on-range and the off-range systems reinforce each other and afford a double check on consistency of data during a mission. Either system is capable of performing the mission alone, but both are needed to ensure flight safety at all times. The missile has now been in flight less than a minute. First stage burnout takes place on schedule.
Ready to take over White Sands?
Looks like a good flight.
Roger. The second stage should ignite in a few seconds. Ignition on time.
At second stage ignition, all displays indicate a normal flight. From the launch area and several other points, precision radars gather position data and instantly transmit it to the White Sands digital computers. In a matter of microseconds, the computers process the data and send pointing information to downrange tracking instruments so that antennas may be properly directed at the oncoming missile. The computer, maintaining an accuracy of approximately 1% of the range, also actuates the flight safety plotting boards. The second stage motor shuts off. The plot indicates impact within the predetermined area. The prediction was accurate, and soon recovery teams were at the impact sites. Recovery of the missile ensures security of classified parts. It also provides material for post-flight analysis, a consistent source of valuable data. Things do not always go so smoothly. Some flights must be interrupted for safety reasons. Let's take a look at two different missions requiring flight safety action. This is the first round. The second stage ignites. Everything looks normal. But watch what happens. Here, the first sign of trouble appears, and the missile flight safety officer prepares to cut down the missile. The plot indicates that the Pershing will fall short of the missile range. The safety officer must choose the most favorable off-range impact area. He considers all possible alternatives and uses all data available. Now, the plot indicates impact in a suitable area, and the safety officer gives the signal.
Cut, cut, cut.
Cut, cut, cut.
The debris from this round landed in an uninhabited area, causing no damage to either life or property. Here, the second stage of another round ignites normally. Again, a missile failure made flight safety action necessary to assure safe impact.
Cut, cut, cut.
These have been highlights of missile flight safety actions for off-range firings into White Sands missile range. To date, at White Sands, where missile flight safety operations for overland missile flights were pioneered, the record is clear. No loss of life has resulted from the thousands of missile flights conducted to date, and property damage has been negligible. This is a record that White Sands Missile Range and its missile flight safety personnel are proud of and continuously strive to maintain.